Hey guys, welcome to today's lesson from Tuesday's class. This is section 2.6 and it's called Implicit Differentiation. Implicit differentiation. And then if you guys wouldn't mind flipping to the back, I just want to show you a quick example of what does implicit really mean in case you don't know or remember. So just flip it over so you have some blank pages on the back. So most of the equations that we deal with have been explicit. And explicit means they're written as y as a function of x. Actually, make this a minus. Doesn't really matter. So an explicit function is when y is already like isolated and written as a function of x. Whereas an implicit function or equation would be written something like this, where y is not solved for. It's still a function of x in the equation, but it's not been isolated. Okay, so explicit is when y equals, implicit is when y is not actually written as a function of x, but it still is. Okay, so that's a quick difference. Today we're going to learn what if you guys have an equation where it's not easy to isolate the y and calculate the derivative, right? Like what if you actually have to find it in this form? Okay, so this is what we're going to be doing today. And what it really is, it's going to be chain rule. So as a little warm up, do you guys remember how to find the derivative of f of x to the fourth power? So this would be like, we would just use chain rule, right? So the 4 would drop to the front, and it would be 4 times f of x, whatever that function is, to the third power, but then don't forget, you'd have to find the derivative of that inner function by chain rule, so times f prime of x. Okay, let's do it where we call f of x y. Okay, so what if I asked you guys to find the derivative of y to the fourth power? Let's do the exact same thing. So the 4 is going to drop down in front, and it's going to be 4 times y cubed, but then because y is a function of x, we then have to find the derivative of y in terms of x. Okay, so then we'd have to find y prime. Okay, so same thing, f of x is just y. All right. Let's try some. So example 1, it says find y prime. Now y prime means find the derivative of y in terms of x. And remember guys, y is just a function of x. So anytime you do y, you're going to have to use chain rule. Okay, so what we're going to do first is find the derivative of both sides. Actually, of every single piece. So we're going to find the derivative in respect to x of the 5x squared minus the derivative with respect to x of the 4y squared, and then equals the derivative with respect to x of the constant 10. We're just going to find the derivative with respect to x of every single term. All right, let's do it. Now for the first one with the x, we can just use the power rule trick, right? So the 2 drops to the front, and that would just be 10x, right? Subtract 1. That one's easy. Now this one, since you're finding the derivative of y, but y is a function of x, we're going to have to use chain rule. All right, so the derivative of 4y squared, the 2 is going to drop. We're going to use power rule. It's going to become 8y. But then you need to multiply by the derivative of y in terms of x. So you can call it y prime, or you can call it dy dx. It just means the derivative of the y function then in terms of x. All right, and then on the right hand side, the derivative of a constant is just 0. Okay, so now we're trying to get y prime by itself because we're trying to solve for y prime. So now you're just going to use your awesome algebra skills to isolate the y prime. So I think I'm going to move this whole term over to the other side to make it positive. And then I have 10x equals 8y times y prime. Right, I just added it over. And now to solve for y prime, I'm just going to take the 10x divided by the 8y. Right, that's how you would get y prime. And then why not reduce it? Y prime ends up being 5x over 4y. And that's it. Okay, so again, all we did was take the derivative of each term. For the x term, we could just use power rule, but for the y term, we use power rule, but then chain rule to get the derivative of the y in terms of x. Okay, so all this is chain rule for the y. Let's try another one that's a little more complicated. Okay, so number 2. It says find the slope of the normal line. And you guys know whenever it says slope of a tangent line or a normal line, it really just means find the derivative, right? So we're going to kind of start this off the same way. We're going to find the derivative of each term because this is an implicit defined function, right? Okay. So we need to find the derivative in terms of x of the first term, which is sine x times y squared. And then we need to find the derivative of the second term, which is 4y, equals, and then we need to find the derivative of the 12, which is the constant term. Okay, so let's go ahead and do each piece. Now, what are you guys going to have to do for this one? It's the product of two functions. The derivative of a product, we have to use product rule. All right, so product rule says it's the first function, which is sine x, times the derivative of the second function. Now the derivative of y squared, we're going to start with power rule, and it's going to be 2y. But then chain rule says because y is a function of x, we also need to find the derivative of y itself. Okay, and then continuing product rule, the second part is the derivative of sine, which is cosine x, times the second function, y squared. So this is all product rule for this first derivative. All right, let's move on to the next one. The derivative of just 4y. Okay, well, you guys know the derivative of 4y is just 4, but then chain rule says that the derivative of y we need to find as well. So I'm going to attach a y prime. All right, and then that's going to equal the derivative of a constant you guys know is just 0. And now what we need to do is solve for y prime. Let me get a new color here. Okay, so this term has a y prime and this term has a y prime, which means I'm going to move the one without the y prime over to the other side. So we have, and I'm going to write this a little different, we have y prime times sine x times 2y plus 4y prime, and then this guy moved over to become negative cosine x times y squared. Okay, so all I did here was put the y prime in front. No reason, it's fine. And then, since we want to solve for y prime, let's factor out the y prime, and we'll be left with sine x times 2y plus 4 equals this negative cosine x times y squared. And then to solve for y prime, we'll simply just divide by all this. So y prime will be negative cosine x times y squared all over sine x times 2y plus 4. So that's going to be our y prime. Okay, but this one we're not done. This one says find the slope of the normal line at a certain point. Okay, so it's saying at the point 0, 3. So let's go ahead and start by plugging in x equals 0 and y equals 3. So what is, because remember, y prime is just the slope of the tangent. Okay, so the slope of the tangent, if we plug in 0 and 3, let's see, negative cosine of 0 is negative 1 times y squared. Y is 3, so 3 squared is 9. Sine of 0 is 0 times 2 times y, and 2 times 3 is 6, and then we have plus 4. Okay, so if you guys work that out, that ends up being negative 9 over 4. Oh, you can't see that. Okay, so that's the slope of the tangent line. Therefore, the slope of the normal line is the opposite reciprocal. So your final answer is positive 4/9. All right, guys, that is implicit differentiation. Your homework is worksheet 2.6. I feel like I changed it to 1 to 17 odd. So go ahead and do that on the worksheet, 1 to 17 odd, and then we'll be spending a couple days on this. All right, thanks for watching.